Hey, Internet. So, we're all going to be talking to AI instead of typing to it soon. Just think about it. We can speak roughly 150 words per minute instead of just typing 40. Now, AI voice isn't just going to be a feature, it's going to be the main interface, the main thing that's between us and AI going forward in the next decade. But here's the main problem most people have no idea how voice agents work in the background and the critical constraints associated to them today. In today's video, I'm going to go through exactly that how they work and the associated constraints. With that being said, let's get into it. Okie dokie. So, as always, we have a beautiful image given to us from the GPT gods. If you can guess the inspiration of this art, where it came from, I will give you a heart in the comments, a big fat heart. I'll give you a hint. It starts with an A. That's all you get. All right. So first things first is let's talk about how voice AI agents functions in the background. And there are probably three main paths of this. So we'll draw this up here. So that's a big one. Let's undo that. All right. So we got one, two, three, and then we'll add a 2.5 here in the middle, and I'll come back to that later. So variation one looks kind of like this, where we have a voice capture piece. So this is the mic, the laptop, the phone, the thing that's capturing your audio. Once your audio is captured, we're going to convert that audio from speech into text. There's many reasons as to why we're going to do this. One of which is it's faster and it's cheaper. So once we've converted your voice into text, we're going to feed that text into an AI to think about something or take an action. Once they've done that, they're going to spit back the response. That's going to be then converted from text to speech via another model. And that's going to then be read out to you as if you're speaking to it back and forth. So that's the audio playout. That's version one. That's the most basic variant of voice agents. That's what we were doing roughly, I'd say, 6 to 12 months ago. Now, what's happening next and the more advanced models today, they have a new addition. And this new addition sits just around here. And this new addition is an acronym called VAD, because we love acronyms. And this stands for Voice Activation Detection, I think. Pretty sure it's what this stands for. And for voice activation detection, the premise of this tool is to figure out when to interrupt you without being awkward. That's like the main purpose of this. And as you probably know, it's very hard to do this. If you've ever been in a group meeting at work and there's that awkward person that doesn't necessarily know when to socially cue the rest that they're done, or if you're on the phone and the connection's really bad and you're not really sure if the person's done or not, and you're trying to interrupt, but you don't want to interrupt, so you're trying to figure out when to interject. That whole concept is what this specific tool as well as model tries to achieve in figuring out when to interrupt. That's version two. That's the improved version of voice agents because it improves the experience that the user has. So that's the number two here. Now, number 2.5 in between these is this addition that I'm calling out down here, which is instead of simply just sharing text to the model, we're going to share all of the previous conversations we've had with the AI. So, say we've had a back and forth 8 times with an AI, and seven of those eight, what we're going to do is we're going to convert all of that to text. We're going to summarize and synthesize it. Once we've done that, we're going to pass that into the AI with the speech from the most recent conversation. So the first seven are going to be summarized, and the eighth is going to be just the speech from the user. The reason we do this is there's a lot of nuance that's lost when you dictate speech to text. And we want to keep that nuance so the AI knows exactly what it's being said and how it's being said so it knows how to respond effectively. So that's 2.5 right there. And then number three, and this is kind of the holy grail that everybody's trying to get to, which is speech to speech. And there's already models that do this today. So I'm pretty sure OpenAI has some models that do this. I know Gemini definitely does. So there are different models out there today that allow you to do speech to speech, meaning that all of this stuff here, so the conversion to speech to text and the text to speech is no longer there. We're just conversing back and forth with the AI. The issues with this is one, it's not as fast as it should be. So it's not as realistic as you would like it to be for the human. But two, is the back and forth is hyper expensive. And the reason it's hyper expensive is if you know anything about context windows with AI, their context window is limited. So we can only put so much in there before it runs out of space. And right now, text is the smallest format factor that we can fit the most into AI's head. When you convert audio, when you put audio into the context window, it expands it drastically. When you put video in, it expands it even more. So once we have context windows that are somewhat infinite, quote unquote infinite, then we can add audio in there and we can have that speech to speech experience that we all want. because in the end, this is going to have the highest quality because the AI has all the nuance in the associated conversation and not just the text from the conversation. So that, my friends, is how voice AI agents work. So now that we have an understanding of how these function in the background, no, haha, almost got me. The last thing I want to say here is, in addition to chat and going back and forth, there are tools. And these tools are important because it allows the AI to take actions instead of just talking to us. And the first point here is that one tool, and these are just some tools, and these are the recommended tools to start with because they're constrained and you're not going to run into a bunch of errors and issues, which we'll talk about later. But here, we have a tool where you can book appointments. So this is a very common thing you can do for hairstylists or whatever else. Another one is looking up a specific thing. So in this case, we're looking up order statuses. But if there's a specific element that an AI can look up, that's another great tool call for voice agent. And then another one is transferring. So if you've had a conversation with an AI, you've gone back and forth, and you've reached to the point where it's all right, the AI can answer my next question. The AI is going to then transfer the call to a human. So these are very bite-sized tool calls that the AI can take without going off the rails or calling the wrong tools. So these are some good examples of what you would want to use if you're using a voice agent and tools associated. Okay, now that we have this done, I probably should give credit where credit is due because I forgot to do that at the beginning. And this here, my friends, is the blog post that most of this content is coming from. So this is a massive blog post. It's probably 130 to 140 pages long, and it was written by a series of authors. These authors both wrote this post and also created a framework called PipeCat, which is an open source thing that I'll talk about later. But in here, they talk through tons and tons of stuff. So 140 pages is a lot of context. I will not go through all of this, obviously. I'm just going to do a synthesized version of what I think is matters most to the larger audience. And that's what we're talking through here. So credit where credit is due. If you're interested, read the blog post. If not, keep watching the video. All right, so now we understand how these operate. The next thing I want to talk about is, why do these work today? So, what makes today the reason that AI is so prevalent? Because there are millions of conversations happening with AI today, and there will be probably billions happening in the coming months. And the primary reasons that I've concluded are speed and cost. I would probably add intelligence to that as well, but I think these are the two primary factors. And we'll start with speed. So, when it comes to talking to AI, speed is everything. So, how fast the AI responds to you determines if you think that it's a robot or if it's a human or if it's a good experience you enjoy. And a great way to measure this, and a way that a lot of providers don't measure and they should, is through this approach. And the providers that give you metrics on how fast their AIs respond, it's not their fault. It's just how they measure in general, not for voice, but just in all use cases. But ideally, if you're doing a voice use case, you want to measure it this way, where you're recording the conversation, where you take your phone or your Mac or whatever else, and you record the conversation. Once you've recorded it, you're going to take that recording and you're going to shove it into an editor. So it could be, uh, I don't know, Adobe, Shotcut, KDN Live, GarageBand, whatever editor you want to put it into. And you put that audio in there so you can then count between when you ended and when the AI started. You count these milliseconds, and that is going to give you a good understanding of how long it takes for the AI to respond. You want to get that time frame down as small as possible. And the metrics I'll show probably over here in a second is the ideal width for this is going to be 500 milliseconds. That's the goal. The max you can have here for some use cases is 800 milliseconds, but the ideal is 500 if you can. Now, how do we break this down? Well, this next chart from the blog post is giving you the full journey of a voice agent and the associated time for each one of those steps in that journey. Instead of going through all of these steps, I just wanted to show there are a lot of them. I wanted to highlight that the only of these steps, three of them take up roughly 80% of the entire time spent. And that goes to the point we've discussed previously already, where a lot of this time is dedicated to either converting text from speech. So from speech to text is a huge portion of this. The next big portion is the thinking portion. And the last portion is converting that text back to speech. Those are the three steps that take the most time. I think I've already mentioned this, but I think GPT 4.0 and Gemini 2.0 Flash tend to be the best models when it comes to intelligence for speed. That's like the best trade-off. And over here, you can see a comparison of these models as well. So you have all the models here. You have the median speed, and then this is worst case. So if worst case scenario, this is how slow they can be. And on the median case, you can see Llama 4 on Grok is pretty fast, and then GPT 4.0 Mini is pretty fast. But like I said, when you want to compare intelligence for speed, 4.0 and 2.0 Flash, actually 2.0 Flash by far is the fastest when it comes to intelligence, but 4.0 is a pretty good option as well. Sadly, 3.7 Sonnet is super duper slow. Sonnet 4 is probably even slower, or maybe probably equally as slow. And that's an issue and a thing that we'll kind of get over time as infrastructure gets built out for these AIs. But that's a thing to consider here and to keep watch out for is speed. That's part of the reason why we're able to do things that we are to today. Next is cost. So the reason we're able to use voice agents today is because the cost for using these agents has dropped drastically over time. And this chart here shows you, and let me zoom in so you don't get distracted by the other. We'll do one of these. So boop, so you can see it. All right, so this here is 4.0 and this here is 2.flash. What we're showing are three different types of conversations: 3 minutes, 10 minutes, 30 minutes. So the good news is if we reverse 18 months ago, each one of these models have roughly 5x'd their cost reduction. So 18 months ago was 5x more expensive to have these same conversations, and it will likely continue to drop drastically on that cost. Bad news is when you extend the length of the conversation from 3 minutes to 10 minutes to 30 minutes, it's almost an exponential increase in cost. So even though here Gemini 2.flash is drastically cheaper than 4.0, as you can see from the prices, it goes from 0004 to 004 to 03. So that's an exponential increase, almost 100x increase in price as we increase the conversation length. So that's one thing to take into consideration when using these voice agents and also building them is if you're going to have long running conversations, you'll need to leverage different types of tactics to lower that cost and ideally not have such long conversations with more expensive models. And as I said previously, the good news is the intelligence of these models is increasing as well as the cost is dropping for those models. So here is a chart that shows you how much it costs for inference on these models and the release date associated. So you can see it's just a drastic drop for all these models when it comes to cost. And that's thanks to the massive infrastructure buildup that's happening all around the world. So these are the two reasons as to why AI voice is becoming so prevalent today. The next thing here are use cases. So we have a win and a fail. So the fail, we'll start with the fail because it's kind of funny, is McDonald's. So this was back, I think it was in March 2024. It was definitely 2024. I don't remember the month. But McDonald's partnered with IBM and they wanted to create a voice agent that they could use in the drive-through. So they deployed this at 100 locations. And in those 100 locations, there was a lot of mess ups that were occurring. And one of the funniest mess ups was there was a lot of people putting stuff on TikTok and Instagram where the AI ordered roughly 200 chicken nuggets for somebody on accident that cost $210. And they ordered a milkshake with bacon inside of it, which is both savory and sweet. Now, the key point here is that the model, when they tested it, had an 85% accuracy rate of success, which sounds good. But the issue with this use case is that it's too open ended. And that's something we'll talk about in a second. But the use case that you choose for your voice agent today needs to be constrained and templated. If it's open-ended and chaotic and the user can really do whatever they want, you're likely going to have a lot of issues. At least today. In the future, probably not. But right now, that's what McDonald's experienced. So let's look at a winning use case. So this was a success where a bank in Europe, ABN AMRO, they utilized an agent they called Anna, where it was acting as a customer support agent in their call center. And it was having, it is currently and probably having more now, 3.4 or 3.5 million conversations per year. And they automated 50% of the customer interactions that they had for their call center. That's a massive drop in cost and also hours spent by those call centers. So this is a great example and use case as to the benefits associated to voice agents and likely many of the benefits we're going to see in the coming months and years for voice agents. And as I mentioned, the main pattern we can take from these use cases and the main lesson learned is that when you're choosing your use case, it needs to be structured in a certain type of context and environment. There needs to be a clear workflow for the voice agent, and the outcomes need to be defined. So we need to have as many constraints as possible to not allow the agent to go crazy. Because if we do, it's going to be struggle and it's going to have kind of chaotic responses and do things that shouldn't. At least today. Like I said, in the future, that's probably going to be different because we're going to have smarter models that are faster and cheaper. So that is our win and fail. Next is going to be the constraints. So these are the primary four constraints that one needs to consider when utilizing AI in a voice context. So the two we have here that I've already talked about, which I'll quickly go through, are speed and cost. So speed, like I've said, latency is everything. And ideally, remember, 500 milliseconds is the ideal use case. And the reason being is roughly half a second and a response time from an agent is the most it gets past the uncanny valley. So the robot becomes more human, and the human that's interacting with the robot feels more heard, and it feels more, I would say, interactive and less robotic in a sense. I can't really think of a better way to say it. And then remember, the max is 800 milliseconds for certain use cases, but ideally 500 is where you want to go. And if we do some of the math as an example, assume that we're doing 800 milliseconds just to be kind to ourselves for our first prototype, and say that our speech to text translation model takes roughly 150 milliseconds. Our text to speech model, so we're going from text to speech, 190. So that only leaves us 460 milliseconds for everything else, not just for our model to think, but all the other steps that I showed you previously. So it's critical that you choose fast models and you choose the right models for the right use cases. All right, next is cost. So we've already talked about this as well. So I'll quickly talk about one thing, which is the cost trap, and that was the exponential increase in time spent with the AI and the associated cost for that. So if you're going to have long conversations from 3 minutes to 30 minutes, note that that increase is going to go from, this is just an example, this isn't realistic, but 4 cents to $4. It's going to be a massive jump. If you're going to do that, one great tip to consider is to summarize previous conversations like I mentioned. So that's the 2.5 example. So when we talked about the 1, the 2, the 3 use case, and then between those we have the 2.5. In that use case, we can summarize all previous conversations in text format, and we can then pass off the final conversation in text or speech to the AI. So you're not taking up too much context window and extending your ability to have longer conversations without increasing the price. All right, so those are the two we've already covered. Now let's talk about the two others to conclude our four. So the first one here is turn detection, and this is in line with the VAD concept I mentioned previously. So the voice activation detection idea. So turn detection is key. Reason being is that when you interact with the user, depending on how long it takes for you to respond, kind of dictates how awkward the conversation is going to be. So, a static way of doing this that a lot of use cases and a lot of voice agents use today is simply waiting zero point 0.8 seconds. So, if the user has been silent for zero point 0.8 seconds, I then, as an AI agent, will then interact via voice. This is a very rudimentary way of doing things. And luckily, there's a lot of tools that are coming out today that are more advanced in the way that they detect when to interact instead of just a simple number. And here are two examples. So Smart Turn is an open source variant, and OpenAI has a variant as well of semantic VAD. So this is a semantic way of deciding when to interact. An example is if I'm speaking to an AI and I say for an elongated time at the end of my sentence, that means I'm probably not done speaking. That means I probably am thinking, so the AI is going to extend its time before it responds. Another way is how I end the tone of my voice. So if I end at a high, I may be either yelling at something, or I may be asking a question. Or if I end low, I may be thinking, or I may be sad, or whatever else, and that'll dictate if I'm likely going to say something else or I'm going to stop. So this is a more advanced way of determining when to decide for the AI to interject or not. And then lastly is tool use. So like I said previously in previous videos, um, tool use is great, and the models are getting more advanced. But the issue with tool use and function calling is the more tools your AI calls and sequence, the chances of it failing increase. So its ability to call them more effectively decays drastically. And these are for the most advanced models. So that's Sonnet 4, Gemini 2.5 Pro, etc. And those models we can't put into voice agents yet. So if that is true, then we need to ensure that the number of tools we're calling with these voice agents is limited to maybe one or two, and they're very defined based on a certain context. And here's an example from the blog that kind of shows you this function calling process and a tip associated to it. So when you call a tool with a voice AI agent, you're automatically going to increase the amount of time it takes to respond. And you probably experienced this tactic or trick with OpenAI. So when you talk to OpenAI's voice agent and you ask it for it to search online for you, so it's hey, go search the stock price of whatever, it's going to make that weird noise. It's like do 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 do, but it's like you know what I mean. It's something like that. And that weird noise that it makes is it's a sound signifying to the user that, hey, I'm doing search, I'm working on something, I'll get back to you soon. And that's one way of kind of relieving the human's need for a response. So they're adding wait tones or music or something like that. Another way to do this is simply telling the user. So when the user asks you to do something, you can go back to them and say, hey, I'm going to go search that for you, and I'll be back in a second. And you go off and you maybe play some tones to let them know that you're working on it and they're not necessarily waiting for no reason. Another thing you can do is letting them know that you're going to go do the thing, do it asynchronously, and then ask them, say, hey, while I'm working on that, are there any other questions you have for me? So you're still engaging with the user and asynchronously doing the tool call. And this is what the general flow looks like. So we have the user comes in, the tool call happens here. We see that there's a massive inference increase, so how much time it takes to respond because of the tool call. We then pass that tool call result through the LLM and then back to the user with the final result. And that's the overall flow that one would experience. And here, these are the four constraints that we need to consider. When you're building voice agents, and also when you're looking for what future voice agents will look like, is as the speed increases for these models, as the cost drops, as their ability to detect when to interact with the user and when to interrupt, and also their ability to call tools effectively with a cheap model and fast models, that's going to increase the ability to do more complex tasks with these voice agents, and which means we're going to interact with them more often. So these are the benchmarks we can check and track for seeing when they're going to come, and also what we need to consider when we're building them ourselves. And the last thing I want to leave you with is if you're interested in building your own agent just to play around with it or put it into your business, there's a few considerations I want to list that are somewhat opinionated that I pulled from this blog post and kind of aggregated myself. First and foremost is you need to pick a use case that's structured. Don't do something that's open-ended because that's going to just breed chaos. So some examples is appointment setting. So if you're doing appointment bookings, you can do that with an agent. So if it's a style salon or maybe even just a SaaS business that's booking calls with prospects, etc. And others, if you're looking up something simple, so such as an order. So if you're looking at one thing that's easily searchable, you can use a voice agent. Surveys. So if you're doing a survey for users and you want to get feedback from them via voice, this is another great way to do that. But don't leave it open ended and don't allow them to basically do whatever. Keep it constrained. Another thing is use Pipecat. So start with Pipecat for your prototypes, your beginning production applications. And the reason you want to use Pipecat is because it's done all of the hard work for you. I've skipped over a ton of stuff inside of the blog that's very complicated and convoluted. And if you don't necessarily know how packets go across the internet, infrastructure associated to Kubernetes and a bunch of other things, you just want to use what's already built out there for open source, so you don't have to jump that learning curve and experience that learning curve. You can just work on somebody else's shoulders. The third is the models to choose. So these are just some models to choose. You can really choose whichever ones you want. But if you're going to do version one of this process to start, if you're going from speech to text, DeepGram tends to be one of the faster models for that. For the thinking models, when it comes to voice agents specifically, 4.0 is pretty good, like I've stated previously, for intelligence to speed. But also 2.0 Flash is likely just as good, if not better, when it comes to intelligence to speed. And then lastly, when we're converting that text back to speech, Cartesia is really fast. But also we have 11 Labs. So 11 Labs is really, really strong when it comes to sounding very human when speaking back and forth with the user. But that comes with a trade-off. That means that its response time is a lot slower. So that's just a trade-off one needs to consider when building out this kind of thing. Again, our max for the voice to voice, so back from user to AI, 800 milliseconds is the top. Ideally, we're going to 500. So you want to aim for 500. If you get to 800, that's okay. But try to aim for 5. Also, turn detection. When you're using turn detection and you're trying to figure out when to interrupt the user, if your if your AI is interrupting the user more than 5% of the time incorrectly, you want to fix that. You want to figure out what other tactics can I use to interrupt the user more effectively without ruining the experience. So that's something to track. I've given you tips and tactics that people have used in the past. And then in the end, like any other engineering project that you're building, start simple and then scale. Don't do anything too complex. Start with a small use case inside of a larger workflow. Try to automate that piece with a voice agent, and then over time you can expand the complexity as well as the number of users that use that piece. And my friends, this is the video. So I hope you enjoyed this. Hope you found it useful, entertaining, all that stuff. If you did, reshare it with your friends. And if you'd like to work with me, I have a company called Gradient Labs. We help other organizations implement AI internally to automate their processes, helping save time, money, and sometimes generate revenue. So if that's at all interesting to you, below is a link where you can book a call with me for a free 30-minute discovery call to see if there's a good fit. And with that being said, Internet, I'll see you next time.